Hey guys, my name's Tessa Mecca, and I'm a junior at Seton Hall University. I'm going to be creating a mini vlog series that will be discussing a major disruptive technology that has arrived in the healthcare industry. The disruptive innovation that I'm going to be discussing is going to be all about tissue engineering. The topic of my vlog today is going to be about the basis of tissue engineering, what it is, how it works, the history behind it, and lastly, how it has become a disruptive technology. So tissue engineering is a division off of what is known as regenerative medicine. Regenerative medicine has four different divisions and means to restore the structures and functions of the damaged tissues and organs. So let's talk a little more in depth about what tissue engineering actually is. According to the National Institute of Biomedical Imaging and Bioengineering, tissue engineering is the practice of combining scaffolds, cells, and biologically active molecules into functional tissues. A few examples of engineered tissues that have been approved by the FDA are artificial skin and cartilage. So now that you know what tissue engineering is, I'm going to explain how it actually works. According to Nina Tandon, which is this TED Talk that I watched, she talks about how tissue engineers use induced pluripotent stem cells. A pluripotent stem cell is like an embryonic stem cell, but without the controversy, she says. The tissue engineers induce these cells by adding a few genes to them, culturing them, and then harvesting them. After that, the cells are then tricked into an embryonic state. And lastly, the cells are placed on a scaffold, which is a natural synthetic that is shaped as a body part and is used for the structure to grow. Here's a picture of a scaffold of ears, which is created through 3D printing. Here you can see the 3D printing of the ear. So with this 3D printing and with the scaffold, you can create any type of cell, any type of organ out of it. You can create a heart, a kidney, a liver, whatever the patient needs. But the most important part of this whole thing is that they're your cells. So this will cut down the need for getting an organ transplant from somebody you don't even know. And this will also reduce the chances of your body rejecting the new organ that is put in. So, according to Dr. Joseph Vicanti from Harvard Medical School, the ultimate goal of tissue engineering is to replace a structure with a completely living structure that is not biohybrid. Biohybrid means part living, part mechanical. So eventually they want to be able to create structures that are completely living and completely you. Next, I'm going to talk to you about a few examples that are, according to CBS, have been used. This is Angela. She is 5 years old, and during a 12-hour procedure, doctors took bone marrow from Angela and extracted certain cells, seeded them into a 5-inch long biodegradable tube, incubated them for 2 hours, and then implanted the graft into Angela to grow a blood vessel. She previously was born with a heart that only had one functional pumping chamber. So after this, and 2 years later, Angela needed a crucial blood vessel. Researchers built her one in the laboratory using the cells from her own bone marrow. Today, she is a healthy, happy 5-year-old. Okay. So next, let's take a look at the history of tissue engineering. In 1954, Dr. Joseph Murray constructed the first successful organ transplant of a kidney. And then after this and into the 60s, many doctors started to give organ transplants, the most common being the pancreas, the kidney, the liver, and the heart. Since our technology has greatly improved in the past 60 years, doctors now give about 5,000 transplants each year. While that may seem like a lot, there are still over 100,000 on a waiting list until an organ is ready for them. The hope is that one day the lab-grown organs will help with the shortage of donated organs. As you can see in this article, there are over 120,000 people needing a life-saving organ. There were 18,000 transplants performed this year, and there were only 8,000 donors as of July 2015. It also says that every 10 minutes somebody is added to the national transplant waiting list, and on average 22 people die before they even get their transplant. But with this new tissue engineering, this will be a thing of the past. We won't have to wait for people to die in order to use their organs. We will have one made on a petri dish in a matter of days or weeks. Lastly, I'm going to tie in this topic with the main reason for this blog, and it is, what industry does tissue engineering disrupt? Before I tell you, I'm going to explain to you what exactly disruptive innovation is. According to Carnegie Mellon University, disruptive innovation is basically when an innovation improves a product or service in a way that the market does not expect. In this case, the industry that tissue engineering is affecting is organ donations. Once this technology is used in everyday medical practices, people will no longer have to suffer or even die while being on the wait list. Instead, we will soon have organs that are created with our own tissue and made on a petri dish in a short period of time. With this innovation, creates the ability for humans to live longer, healthier lives. But with the ability to live longer and healthier lives, it also comes a lot of social implications that I will explain that to you in our next video. So next time I'm going to talk about the social implications of tissue engineering and the pros and cons of it, because as it's such a great thing, there's also bad things that come out of being able to live forever